B. Kavita, Assistant Professor in Physics. Today we discuss magnetic materials. Magnetic materials. Okay. What is magnetism? Magnetism is the attracting property exhibited by the magnet is known as magnetism. Attracting property exhibited by the magnet is the magnetism. Magnetic dipoles. Magnetic consists of north and south poles. Any two opposite poles are separated by a finite distance constitute a magnetic dipole. Magnet consists of north and south poles. Any two opposite poles are separated by a finite distance constitutes a magnet dipole. Magnetization. The magnetization M is defined as the magnetic moment per unit volume. Magnetization is defined as the magnetic moment per unit volume. Magnetic susceptibility. The magnetic susceptibility chi is defined as the ratio of magnetization produced in a sample to the magnetic field strength. The ratio between the magnetization and the magnetic field strength is called the magnetic susceptibility. Magnetic lines of forces. Magnetic lines of forces. The magnetic field is characterized by magnetic lines of forces. Magnetic field is characterized by magnetic lines of forces. If M is the magnetic pole strength and L is the length of the magnet, then its magnetic dipole or magnetic moment is given by the product of M into 2L. So, magnetic moment we find the product of one pole strength M and the distance between two poles 2L. The product of these two gives the magnetic moment. When an electric current of I ampere of flows through a circular wire of one turn having an area of cross section A, it is said to have magnetic moment of 2 is mu is equal to magnetic moment of I by A. Magnetic moment is I by A. Magnetic field. The space surrounding the magnet up to which its attracting influence is felt is known as magnetic field. The space surrounding the magnet up to which its attracting influence is felt is known as magnetic field. Magnetic field strength. Magnetic field strength. Magnetic field strength H is the force experienced by a unit north pole placed at a given point in a magnetic field. Magnetic field strength H is the force experienced by a unit north pole placed at a given point in a magnetic field. Magnetization or intensity of magnetization. Magnetization or intensity of magnetization. The magnetic moment per unit volume is the magnetization or magnetic intensity. Units ampere per meter. Magnetic susceptibility. The ratio of the magnetization produced in a sample to the magnetic field strength. Magnetization to the field strength is called the susceptibility. Chi is equal to M by H. Magnetic lines of forces. The magnetic field is characterized by magnetic lines of forces. Magnetic induction field strength or magnetic flux density. Magnetic flux density. The magnetic flux density B is defined as the number of magnetic lines of force passing through a unit area of cross section of magnetic material. The magnetic flux density B is defined as the number of magnetic lines of forces. See here, this unit area of cross section A. These are the magnetic lines of forces. The number of magnetic lines of forces passes through the unit area of cross section is called the magnetic field flux density. If pi is the number of magnetic lines of forces passing through a area of cross section of a material, then flux density is equal to pi by A. Units for flux density is Weber per meter or Tesla. Magnetic permeability. Magnetic permeability. The magnetic permeability of a magnetic permeability of a measure of the amount of magnetic lines of forces penetrating through a material. measure of the amount of magnetic lines of forces penetrating through a material. It is defined as the ratio of the magnetic flux density or magnetic field strength B in material to the applied magnetic field intensity H. So the ratio of the magnetic field strength and intensity H, B by H is the permeability. B by H is the permeability. Mu is equal to B by H. B is equal to mu H. Magnetic permeability of free space. The magnetic permeability of free space. The magnetic permeability of free space is a measure of the amount of magnetic lines of forces passing through the air medium. Mu naught is equal to B naught by H. Relative magnet magnetic permeability. Relative magnetic permeability. It is defined as the ratio of permeability of the material to the permeability of the free space. Permeability of the material to the permeability of the free space. Mu by mu naught is equal to mu r. Mu is equal to mu naught mu r. Relation between BHM. B is the flux induced, H is the field strength, B is the magnetization, B is the flux density. The relation both 3BHM, B is equal to mu H, B is equal to mu naught mu R H, B is equal to mu naught H plus mu naught H minus mu naught H. But M is equal to H into mu R minus 1. M is equal to H into mu R minus 1. B is equal to mu naught H plus mu naught M. In those terms here, in these two terms, we common mu naught H and mu R minus 1. Mu naught H into mu R minus 1. Okay. In place, we take M value. So, mu naught H plus mu naught M. Mu naught B is equal to mu naught into H plus M. This is the relation between B, H, M. Next, relation between chi and mu r, relative permeability and susceptibility. We know B is equal to mu naught into H plus M. Previous relation. B is equal to mu naught into H plus M. B by H plus M is equal to mu naught. Mu r is equal to mu by mu naught. So, mu is equal to, we write in place of mu naught, mu by mu r. Mu is the B by H. Mu r is the B by H plus M. H plus M by H, 1 plus M by H, 1 plus chi. So the relative permeability mu R is equal to 1 plus chi. These are the basic definitions of the basic definitions in magnetic materials.